Next problem is find the minimum value of x plus 1 by x whole power 6 minus x power 6 plus 1 by x power 6 minus 2 divided by x plus 1 by x whole cube plus x cube plus 1 by x cube for x is greater than 0. Solution. Given is y equals to x plus 1 by x whole power 6 minus x power 6 plus 1 by x power 6 minus 2 divided by x plus 1 by x whole cube plus x cube plus 1 by x cube where x is greater than 0. Now x cube plus 1 by x cube we can write as x plus 1 by x into x square plus 1 by x square minus 1. This we can write as x plus 1 by x into x plus 1 by x whole square minus 3. Similarly, x power 6 plus 1 by x power 6 we can write as x power 3 plus 1 by x power 3 whole square minus 2. Then x power 3 plus 1 by x power 3 we can write as in bracket x plus 1 by x into x plus 1 by x whole square minus 3 to the whole square minus 2. Now x plus 1 by x will assume as t where x is greater than 0. For finding x plus 1 by x value we'll use AMGM. So AM is always greater than or equals to GM. Here x and 1 by x both are greater than 0. So both are positive number, we can apply AMGM. So according to AMGM, x plus 1 by x divided by 2 is always greater than or equals to root over x into 1 by x. So that will be x plus 1 by x is always greater than or equals to 2 into root over 1. So we can say x plus 1 by x is always greater than or equals to 2. Now for equality these two numbers should be equal. So x equals to 1 by x. So we will get x square equals to 1. So we will get x equals to plus minus 1. Here x equals to 1 is possible. That means x plus 1 by x minimum value 2 possible. So we can say x plus 1 by x is always greater than or equals to 2. And this is nothing but what? T. So t is always greater than or equals to 2. We know t value is x plus 1 by x where t is greater than or equals to 2. Now we'll convert this equation in terms of t. So first thing we'll find out x cube plus 1 by x cube in terms of t, and similarly x power 6 plus 1 by x power 6 in terms of t. So x power 3 plus 1 by x power 3 equal to, this is t into t square minus 3. Similarly x power 6 plus 1 by x power 6 equal to, this will equals to this one. So this will come in bracket t into t square minus 3 to the whole square minus 2. Now equation y will convert in terms of t. So y equals to x plus 1 by x we can write as t. So this will come t power 6 minus x power 6 plus 1 by x power 6 we will write from here. So this will come t into t square minus 3 to the whole square minus 2, and the outside is minus 2 divided by x plus 1 by x to the whole cube we can write as t cube plus x cube plus 1 by x cube we can write as t into t square minus 3 where t is greater than or equals to 2. From here we can write y equals to t power 6 minus t square into t square minus 3 to the whole square minus 2 divided by t cube plus t cube minus 3t. Y equals to, we can write as t power 6 minus into t square in bracket t square minus 3 whole square we can write as t power 4 minus 6t square plus 9 in bracket and minus 2 outside divided by 2t cube minus 3t where t is greater than or equals to 2. So y equals to t power 6 minus t square into t power 4 minus 6t square plus 9 minus plus 2 minus 2 divided by 2t cube minus 3t where t is greater than or equals to 2. So y equals to t power 6 minus t power 6 plus 6t power 4 minus 9t square and 2 getting cancelled, divided by 2t cube minus 3t, where t is greater than equals to 2. Here t power 6 is getting cancelled. So y equals to, in these two terms, if I take 3t outside, we'll get 2t cube minus 3t divided by 2t cube minus 3t. This is getting cancelled, where t is greater than equals to 2. So y equals to, will get 3t, where t is greater than equals to 2. So from here we can say y is greater than equals to 6. So y minimum is 6. This is your answer. Next problem is, find all the values of the parameter a for which the inequality is a into 9 power x plus 4 times of a minus 1 into 3 power x plus a minus 1 is greater than 0 is satisfied for all real values of x. Now solution. So given is a into 9 power x plus 4 times of a minus 1 into 3 power x plus a minus 1 is greater than 0 for all x belongs to R. So this equation we can write as a into 3 power x whole square plus 4 times of a minus 1 into 3 power x plus a minus 1 is greater than 0 for all x belongs to R. Here 3 power x will take as t. We know x is belongs to R, so we can see 3 power x belongs to 0 to infinity. So we can see t belongs to 0 to infinity. So this equation become a into t square plus 4 times of a minus 1 into t plus a minus 1 is greater than 0 for all t belongs to 0 to infinity. Now this equation at square plus 4 times a minus 1 into t plus a minus 1 is greater than 0 for all t belongs to 0 to infinity. So we want to find out a values. So this is a quadratic equation. This equation should be positive, that means a must be greater than 0. If a is greater than 0, so we will have three cases. First is discriminant equal to 0, second is discriminant less than 0, and third is discriminant greater than 0. Now if discriminant equals to 0, so we want curve should be what? Always positive in the interval t belongs to 0 to infinity. So that means what we can say, either root should be 0 or negative. So root should be less than or equal to 0. If discriminant is less than 0, so we can say curve is always positive. And if discriminant is greater than 0, so we can say root should be less than or equal to 0. We will find out d. So d equals to b square minus 4 times of ac. So that will come, b square is what? 4 times of a minus 1 to the whole square minus 4 times of a is a and c is a minus 1. Now we will simplify this one. So 4 times of a minus 1 we can take common. We will get 4 times of a minus 1 minus a. So from here we will get 4 times of a minus 1 into 4a minus a, that is 3a minus 4. Now we will draw number line. So critical point is what? 1 and 4 by 3. Right hand side of 4 by 3 we will get d positive. Between 1 and 4 by 3 d will get negative, and left hand side of 1 will get d positive. So from here we can see d is greater than 0 if a belongs to minus infinity to 1 union 4 by 3 to infinity. Now, d is less than 0 if a belongs to open interval 1 to 4 by 3, and d equals to 0 if a equals to 1 and 4 by 3. If d equals to 0 and a equals to 1 and 4 by 3, we want root should be less than or equals to 0. So we will find out roots. So x equals to minus b plus minus root d divided by 2a is the roots. So if I put d value, so d is what? Equals to 0. So roots will be minus b by 2a. So x will get as minus b. So b is what? 4 times of a minus 1 divided by 2 times of a. So if I put a value is 1, so we will get x equals to 0. And now if I put a value is 4 by 3, we will get x value is what? Minus 4 into 4 by 3 minus 1 divided by 2 times of 4 by 3. If I simplify this one, we will get x equals to minus 4 into 4 minus 3 divided by 2 into
4. So from here we will get minus 4 by 8, that is minus 1 by 2. So we can say for a equals to 1 and a equals to 4 by 3, roots are less than or equals to 0. That means a equals to 1 and a equals to 4 by 3 is possible. For a belongs to 1 to 4 by 3, discount is less than 0. So we can say curve is always positive. That means this is true. So a value is what? 1 to 4 by 3 is also possible. Now, if a belongs to minus infinity to 1 union 4 by 3 to infinity, we know discount is greater than 0. So what we want? Root should be less than or equals to 0. So we want two curves. One is both roots should be what? Less than 0, or one root is negative, other root is 0. So we can say here alpha plus beta must be less than 0 and alpha into beta must be greater than or equals to 0. Now we want alpha plus beta must be less than 0. So we will find out alpha plus beta. So alpha plus beta is minus 4 times of a minus 1 divided by a should be less than 0. So if we simplify this one, we will get 0 and 1 and negative, positive, negative. So we want negative portion because this equation is less than 0. So we will get a belongs to minus infinity to 0 union 1 to infinity. Next we want alpha into beta must be greater than or equals to 0. So alpha into beta, from this equation we can say a minus 1 divided by a must be greater than or equals to 0. If we simplify this one, we will get 0 and 1. This side is positive, negative, positive. So we want this should be positive. So we will take positive portion. So we will get a belongs to minus infinity to 0 union 1 to infinity. So if I take intersection of both, we will get a belongs to minus infinity to 0 union 1 to infinity. Now we'll take intersection of a values from the discriminant greater than or equals to 0. Intersection of these two will get a belongs to minus infinity to 0 union 4 by 3 to infinity. Now we'll take union of all the three cases. So we will get a belongs to minus infinity to 0 union close interval 1 to infinity. Now given is a must be greater than 0, that means negative value is not possible. So we will get a belongs to close interval 1 to infinity. That is your answer.